This is to try to show you how to graphically and, more importantly, algebraically add more than two vectors. So I think you guys remember when we did the graphical adding of vectors that you had to use, you have these three vectors here, 150 west, 100 north, and then 75 at 30 degrees north of east. And you know you have this north, south, east, west. So the first vector goes all the way, it's A, it's 150 this way. So my scale, that would be 15 squares to the left. And then this would be 10 squares up. And in this particular one here, you would put your protractor here at 30 degrees north of east, and you would make it 1, 2, 3, 4, 5, 6, 7.5 squares long. So that is the vector D. So that's, and then you draw, you use your protractor again, and you draw, you draw the line with the ruler from there to here, and then you get that angle. So here I would get approximately 61 degrees, and then when I measure it and I pull it off here with the ruler, I get 163 kilometers at 61 degrees north of west, which is really close to the right answer. Let me call the right answer up for you. Here's the correct answer. So it's 162 at 58.3, right? So very close, off by a couple degrees here and off by 1 kilometer. So not too bad for doing it graphically. Now let's do it algebraically or trigonometrically. So when we do it trigonometrically, we want to put the, show that this vector here, the 150, the red vector here, 100, and then this vector here, we want to resolve into its components. So when we go to add them up, we have to remember something about the quadrants on a, so remember that you have this north, south, east, west. Well, if you make that a little bit larger and you start to look at the signs that the components will have, the sideways and the up and down components of the actual vector have, let me see here. Here they are. So if you look at it, if you go to the right and up, your x and y, or your horizontal and your up, are positive if you're in this quadrant. If you're in this quadrant, your up is positive and your x is negative. If you're down here, both x and y are negative. And then when you go down here, the x is positive and the y would be negative. You just need to remember this when you're starting to add them in a table. So let me see what we got here. So when we start to add these into the table, we'll have to remember the signs of the particular quadrants. So let me go ahead and take this away. Okay. And let's go ahead and take the compass rose away. Now, when we go to add them, you can see here that this vector A is all horizontal. So if you look at it, vector A has negative 150, because look, it's going to the left from this direction, from this starting spot, and it has no vertical part. Then if you look at vector B, it's all vertical and no horizontal. And then if you look at vector D, well, when you look at vector D, you have to look at the actual the components of D. So you see here that this is the x component of D, and that's the y component of D, right? Now we're going to have to find these, and how you find them is using Sohcahtoa. So do you remember Sohcahtoa? Which is this whole idea that the opposite side, the side opposite from the angle, can be found, and the side adjacent to the angle, this is all relative, and there's your hypotenuse. So if we look at the D triangle, you'll see that from what we had up here, and just let me show you the magnitude of D, see the orange circle, and then see the angle of D. So that's where we got the 75 and we got the 30. So this is hypotenuse times the sine equals the opposite, because that's SOA. And that gives me 37.5. And then this is COA, hypotenuse, 75 times cosine 30. And it gives me this. Now notice they're both positive. So let's go ahead and see how that fills in. You see the 37.5 is the vertical, it's the opposite side, and the 64.95 is the adjacent, which is the horizontal side, horizontal bottom side. Now we're going to have to add these up, and you add them up going down like this, and you will get that. Notice it's negative, it's backwards, and it kind of is consistent with our diagram. And then the y components. Now, we have to use the Pythagorean theorem to actually get what the size of this this whole big one is here. Right now we're finding this whole big one. We found the little D triangle, and we kind of need to forget about that now. Okay. And now we're going to use the Pythagorean theorem to, right there, right? When you put this in your calculator, do the negative 85, because that squared is going to go away. Negative times a negative is a positive. And then this squared, square root, equals 161.7. Now remember what our correct answer was. It was 162, so that does round to 162, so that's not a problem. Now, when we go to find our angle theta, we have to say the inverse tangent of, that's the TOA, opposite, which is this right here, over adjacent. Now notice it says negative 58.26, but if you think about it, angles start here and go positive. So if you were to start here and go negative, that would actually be your angle. And notice we wanted 58.3, and if we go to significant digits, that is the correct answer. So that is how you solve it algebraically for the resultant. And that is now this right here, that would be my heading, and that would be what I would report. So, hope this really helps out. And that is it.